Okay, hello and welcome everyone to my session about Delta Lake. So before we get started, some words about me. I'll keep it short. So basically, I'm Gerhard, working with Microsoft BI and data for over 15 years. And yeah, I also active in the community, provide tools and stuff, and the recent years a lot for Spark, Databricks, and also Delta Lake, which the current session is about. So what are we going to see in the next 10 minutes? So first of all, a slight introduction what Delta Lake actually is. The main focus will be on how it actually works. And in the end, I'll give you some things that you definitely need to watch out if you're using Delta Lake in one of your projects. So Delta Lake itself, it's an open source storage format for Apache Spark, which basically allows a lot of features that you know from, let's say, traditional relational database management systems, but apply them to big data workloads. The most important probably one is ACID compliance, so that each transaction that you do is atomic, it's consistent, it's isolated, and it's durable. There are also some other features that, from my opinion, are even more important. It's the support for update and merge. So if you used a data lake with, let's say, a regular format like a Parquet, whatever, in the past, updating data has always been a pain because it basically operates on a file level, and you need to read the file, change it, and write the file again, basically. And if you use Delta, you can just use simple SQL update statements, and Delta will take care of it. Also, as we have transactions in Delta, each operation that we do is recorded, and we have a feature called time travel, which allows us to go back and forth within the time history of the table, so that you can see how a table was before your statement, etc. Okay, there's some other features too, but like these are the official ones, but these are the ones that I think it's more important for, let's say, the regular user. So what's important about the Delta Lake? So it's basically a folder that can reside on any storage. So it's not necessarily has to reside on the data lake. It can also be on your local drive. It can also be on a USB key. And this Delta Lake folder basically contains the data itself, but it also contains like a metadata, partitioning information, and everything that you need to know when querying the data. Delta Lake itself is based on two open source standards, which is Apache Parquet for storing the data and JSON for storing the transactions. When using Delta Lake, you can use multiple processing engines like Databricks, Azure Synapse, HD Insight, Cloudera, whatever, and operate on the same table. So it can be shared across all those processing engines at the same time, as long as you keep in mind that one transaction can only so as long as the transactions are separated by partition. If two or more processes would touch the same partition, like doing an update on the same partition, you obviously have concurrency issues, and one of those transactions would fail. So it's using optimistic concurrency control to basically decide or to check whether there has been another transaction modifying the same data on the partition level. Yeah. Regarding support, so I already mentioned it. So Delta Lake is basically natively supported in Azure Databricks and in Spark. So there is an open source version for Spark, which is also used in Azure Synapse, for example. Some other nice features is that I mentioned before that you can reuse and also restore previous versions. So if you wrote a SQL statement and totally messed up the data and updated or dropped most of it, you can basically just restore the previous version before your SQL statement. And you can also clone tables. So you can do like a clone and then you from a production table and then run your statements or run your pipelines on this clone, which contains the real data, but you cannot modify it or you cannot break it. So that's a really nice feature for development. And the nice part is, regarding languages is that you can use the language of your choice. So there are basically APIs for SQL if you're a SQL developer. If you like to use Python and PySpark in your Spark environment, then you're also free to go. And you can also use Scala. And I think also for Java and R, but I'm not 100% sure on this. So what does a Delta Lake table look like? So as I said, it's basically a folder that can reside anywhere. And there is like one specific subfolder, which is called the Delta log, which contains all the information about transactions. As you can see, it's JSON files, and there is also a Parquet file in there. And you do have the actual data, which is Parquet files again. So it's highly compressed. It's columnar storage. So if you only query for a subset of data, subset of columns, it doesn't have to touch the other one. So there is some headers in there that allow you to read only specific parts of the document of the Parquet file. Okay, cool. So how do you actually create the Delta table? For all the samples here, I used SQL because I think it's the most easy to read language, and probably most people are familiar with it. So you can basically just create table if not exist and the table name, and then you need to specify using Delta to tell Spark that it has to use the Delta format. You can specify partitioning, you can specify a location where you actually want to store the Delta table, you can specify properties, and you can do a select statement to already populate the Delta table. So in this case, like I'm basically creating a Delta table dim product, which is stored on a data lake store or an mount point, set some table properties, and populate it with the content from stage.products. All the column definitions, because usually, like if you do a create table, you need to specify all the columns, etc. It's just taken from the select statement. So that's pretty straightforward. The other case is that you already have an existing table, then you can just create table using Delta and specify the location. Okay. So regarding features, as I mentioned before, Delta Lake supports a merge statement, which is pretty convenient if you need to update the data in your data lake. So if you use to SQL, the merge statement is basically the same. So you specify a primary key, like a source table, a target table, a primary key to join them, and then there can be a match, there can be no match, and depending on what's the case, you can do an update or you can do an insert, whatever. So that's super convenient, especially compared to other file formats that are common to data lakes. So how does it work under the hood? So basically you have a table that has like the log file and one Parquet file underneath that's referenced via the log. If you do an update, what's basically happening, a new log entry is created, a 001.json in this case, which basically says, okay, from the current table, please remove the old Parquet file and add a new one. As you can see at the bottom, both of those Parquet files are still on the storage, so they consume twice the amount of space, but both of them have those 3 rows. So now what happens if I run a delete on this table? So basically delete from product, dim product where product equals PC. So I'm basically deleting the second row. So the result is obviously a table that only contains 2 rows. I do have, again, a log that basically removed the old version, the part 02 Parquet, and adds a new one. So the old one had 3 rows and the new one only has 2 rows. You can also do an insert, obviously. It would just add a new Parquet file and a new log entry. And there, I guess you already see that there is an issue if you have you end up with having a lot of Parquet files if you run a lot of operations. So there is another operation which is called vacuum, which basically allows you to delete the files that are not part of the most recent version of the Delta table anymore. And that's also the key takeaway, basically, that every statement that you execute, especially update, delete, merge, all of them can potentially result in new files being written. And this can create a lot of files, can create a lot of can consume a lot of storage, and can be quite expensive. So whenever you use Delta Lake table, make sure that you are familiar with the vacuum command, what it actually does to keep your storage costs low and to keep your storage costs low. So yeah, and that's it from my side, I guess. Yeah, I hope you got some idea of what the Delta Lake format is, how it can be used, and especially what you need to watch out for.